Okay, last lesson of your calculus career.
Yes! Until next year.
Until next year.
This is the last lesson?
Yeah.
Oh, so no lesson.
Yeah, we're going to review tomorrow for the test. Review on Monday. Test Tuesday. Test Tuesday, Kevin. Kevin's listening.
Still 2 more days for me to drop.
No, you're not going to drop. Jack should, but you shouldn't. All right, here we go.
That's almost right.
Oh, that's okay. Jack, you have that forever. You can... The recording. Jack likes to just skip to the good parts. He would probably just fast forward through that.
I just put you on higher speeds.
Oh, good. All right, integrating using partial fraction. Decomposition. Okay. So now that you know how to break it down, okay, now we're going to integrate. So let me show you, for example, like it's really literally one extra step. So if I had to integrate something like you did this one as number 1 last night. Let's say I have to integrate it now. It's x minus 12 over x squared minus 4x dx, okay? And what you did last night is you took that. That would be really tough to integrate. Like, how are you going to find that? You're going to do anti-quotient rule? Like, what is that? There's no such thing. So you break it down into its partial fractions, and what you did is you got 3 over x minus 2 over x minus 4. So you break it down into its partial fractions, and then you integrate each one individually. Okay? So what happens is you get the integral of 3 over x. Do you know what the antiderivative of 3 over x is?
Natural log of
Yes. 3 natural log of x. And technically they do want you to put absolute values around the x. I'm not really too picky about that. I just assume that you know the domain. Okay? Absolute value?
No, like I know what it means, but like why do you have to do it?
Oh, so the antiderivative of 1 over x is natural log of x. And then the 3 is just the constant. So it's really taking the integral of 3, or 3 times the integral of 1 over x dx.
And you have to put the...
Oh, absolute value, because you can't take the natural log of 0 or negative. So I'm fine if you don't have it. Yeah.
So if it's 1 over x, it's just ln.
Yeah.
Like,
Like even the next one would be minus 2 natural log of the absolute value of x minus 4. I don't really care if you do absolute value or not. It's just if when you look at the book and you have those answers, that's why. Okay, and then don't forget plus c. And then what they want you to do is they want you to combine it all into one natural log. So using Trevor's log properties.
natural log of x over?
So it's going to be natural log of x cubed over x minus 4 squared plus c. That would be it. Yeah, so it's just one little extra step. The hardest part really is the partial fraction part where you break it down. Yeah.
Are they going to give us the denominator like they have been?
Uh-huh.
Okay.
Yeah, so let's do one. Are you ready?
What?
Okay. It's only 2 problems. Yeah, and then you get... No, that was just, yeah. Okay, so here we go. We're going to take the integral of 3 over... I thought you had already done this one, but we haven't. X squared plus x minus 2 dx. Okay. All right, so we're first going to start by breaking this down and finding its partial fraction decomposition. So we're going to go 3 over x squared plus x minus 2 equals, I could have factored there, I probably should have, but I didn't. A over, we could go x plus 2, and b over x minus 1. So you factor this into x plus 2, x minus 1, and then we're going to do exactly what you did last night. We're going to multiply everybody through by x plus 2 times x minus 1. Okay. And then when you do that, you get 3 equals a times x minus 1 plus b times x plus 2. Now, this is up to you. However you want to solve this, if you want to solve this by plugging in x equals 1, you can. I kind of like that. You're doing that right now? Yeah? if I let x equals
It's so
1,
easy. This one's so easy if you just do
it is just a system.
negative.
If you let x equals 1, you will get 3 equals bx plus 2, right? Oh, no, x is 1.
See, I'm already done and I didn't do it.
I messed up. B plus 2. So b is 1?
So, A is negative 1.
Okay. And then if you let x equal negative 2, you get 3 equals negative 1 times a. No, negative 3. I'm terrible at this way. So a is negative 1?
That's easy.
Yeah, I like systems. Okay, so now what we're going to do is we're going to put them back in. So I have negative 1 over x plus 2 plus 1 over x minus 1 dx. And then we integrate. So we get negative natural log of x plus 2. You can use absolute values or not. I'm not picky, okay? Plus the natural log of x minus 1. What you can do is you can take that negative 1 and move it to the top. But you know what you can also do, bless you, is you can just switch them, rearrange them, and it becomes natural log of x minus 1 minus the natural log of x plus 2. Yeah. And so it's just natural log of x minus 1 over x plus 2 plus c. Beautiful. There you go. Okay, you have one, just one of those to do on your test next week. Now, the last one is going to be like the bonus question. So if you're done, you've had enough math for your lifetime. You may, But if you'd like to get this bonus question right on the test, here it comes. Yeah, you do.
Actually, I don't because I have a 4.0.
Oh, you do?
Got a 97 in econ.
Oh, good. And you got it?
But I still want to get a 97.
But you'll be in the program and you'll have your thing?
I don't know.
Oh, I hope so.
I talked to this so.
Okay, so here we go. We're going to integrate 6x squared minus 8x minus 4 over x squared minus 4 times x minus 1 dx. Okay? It's just the thing about this one, it's going to be a 3 by 3.
Yeah.
So it makes it a little tougher. Okay, so here we go. Let's break it down. We're going to have 6x squared minus 8x minus 4 over, and we can factor this as x plus 2 and x minus 2 because it's the difference of two perfect squares. And then we have times x minus 1. Okay, so all I did was factor the denominator, and let's go ahead and set this all up. Are you ready? We have a over x plus 2 plus b over x minus 2 plus c over x minus 1. And we're going to multiply everything through by those. I don't know. I think that other way would be good here. Because you're going to get a 3 by 3. Do you know how to solve a 3 by 3? Do you remember how to do it on your calculator with matrices? A inverse times B?
I think you're not.
I'm okay?
Yeah.
Okay. All right, so we multiply through. And we get 6x squared minus 8x minus 4 equals a times x minus 1 times x minus 2. Doesn't matter what order that's in. Plus b times x minus 1 x plus 2 plus c times x minus 2 x plus 2. Okay. Then you would have to FOIL all these out, distribute, combine your like terms. It would be really bad. So can we try that other way again? Let's try it.
What do you do?
Okay, here's what you do. You have 3 zeros basically. 1, 2, 3. You have negative 2, positive 2, and positive 1. So the first thing you do is you let x equal 1. Okay? We'll just start with 1. Is that okay? So you plug 1 in for every x that you see. All the x's that you see. So we get 6 minus 8 minus 4 equals, This is going to cancel out. Do you see that? Because that's a 0. The b is going to cancel out too because that's a 0. And you're left with c times 1 minus 2 is negative 1. 1 plus 2 is positive 3. So you get what is on this side, negative 6 equals negative 3c. So c equals 2. That's really nice. That's so cool. I've never seen that before. Or maybe I have. Probably not. Okay. Now let's let x equal positive 2. So x is positive 2. No, they're not random. They come from these right here.
First and last one you use out.
Mm-hmm.
You get
And then you're going to solve for b now, right?
B 4b equals
Mm-hmm.
negative. Oh wait, no.
Oh.
We have to do that.
4 equals 4b. Yeah, you got to do this side.
I don't think it's 4.
It's not? All right.
I didn't do math.
Oh, okay. 6 times 2 squared minus 8 times 2 minus 4 equals, and you did that side though? So the a and the c parts will cancel out. This will be 4 times 1, yeah, 4b. Okay, and you can plug that into your calculator if you need to. 24 minus 16 minus 4 is 4.
Yeah,
4 equals 4b, so b equals 1. Okay, I'll give you another option if you want another option, but all right, and then we're finally going to let x equal negative 2 now. And so you plug 6 times negative 2 squared minus 8 times negative 2 minus 4.
Negative 12a.
Yeah? Yep. I think it's positive. No.
Yeah, positive.
Is it positive? So then on this side, yeah, you'll get 12a. Because you'll plug in negative 2, negative 4, negative 3, positive 12a. This side is 36. So 36 equals 12a, so a equals 3. All right, that's just to, break it down. And so now we're going to actually go ahead and evaluate the integral. All right, so here we go. We're going to integrate. We got a was 3, so 3 over x plus 2. B was 1, and that's over x minus 2. And c was 2, which is over x minus 1 dx. All right, and they're all just natural logs. So this one would be 3 natural log of x plus 2. Oh, they're all pluses too. That's fun. Plus the natural log of x minus 2 plus the natural log of x minus 1 plus c. And then we'll put them all together.
You multiply them?
Yeah. So it's going to be the natural log of x plus 2 cubed.
But you forgot the 2.
Oh, 2, yeah. Thank you. That is a 2. It looks kind of weird. And then times x minus 2 times x minus 1 squared, and then plus c. That's pretty cool. All right, otherwise you kind of have to FOIL that whole thing out. Systems with 2x2s, that's not too hard. Yeah, I actually did it all. Look at, I did the whole system. And then I did matrices on my calculator and found it out. But then I wrote, oh, look, another way to solve, and I did it. I wrote it down from the book. Okay, that's it.